In this lesson, we will multiply a single-digit factor by 10. In the last lesson, we looked at the commutative property of multiplication using arrays and area models. We made an array that looked like this, 3 by 4, or 3 rows of 4. In second grade, we used addition to find out how many cubes were in this array, and we now know how to use multiplication to find the same answer more quickly. In today's lesson, we'll be using similar arrays to model multiplication of a single-digit factor by 10. Instead of single cubes or squares, let's use rods. Here are the single units that we used before, and here are our 10-unit rods. We'll make sure that they're the same size by comparing 10 single units to the rod. Instead of making a 3 by 4 array like we did in the last lesson, I'm going to make a 3 by 10 array. How many single units would there be in this array? We can figure it out by writing a multiplication equation, which would be 3 times 10. We could count the single units to find out the answer to the multiplication problem. We could count by tens, 10, 20, 30, or we could just multiply 3 times 10, which is 30. Let's try another example. We'll make an array of 5 times 10. We have 5 rows of 10 units each. Again, you could count single units, or we could count by tens, 10, 20, 30, 40, 50. Or you can multiply 5 times 10, which equals 50. So this array has 50 single units in it. We could also draw this on paper several different ways. On graph paper, we would show 3 times 10. It looks just like the rods that we used. Again, you could count the single square units to find the answer. You could count by tens, or we could just write an equation, 3 times 10, and it would equal 30. In class, your student was shown a multiplication chart and asked to look for a pattern for multiplying by 10. Let's look at it. If we look at the chart, we see that the product of 2 times 10 equals 20. 3 times 10 equals 30. 7 times 10 equals 70. What's the pattern that we're looking for? Each product ends with a 0. Multiples of 10 will always end with a 0. Some of them may have more than one 0, like 10 times 10, which is 100. But all multiples of 10 will always end with a 0. If you'd like to practice a real-world application with your student, try using dimes or $10 bills. Play money is perfect for this. Create problems for them or have them think up their own problems. For example, if Jack spent 10 dimes on cookies, how much money did he spend? Have them arrange the dimes in an array, write a multiplication equation, and solve it. During this lesson, we used unit cubes and 10-unit rods much like we did in the last lesson. We arranged them in an array and wrote a multiplication equation to determine how many single units we had. We also noticed that all products of a single digit and 10 end with 0.